Hello and welcome to this course titled APIs with gRPC in Go. Now, in this course, we will learn how to build modern backend APIs from the ground up, step by step, and we're going to go from basics to building a real-world applications. Now, the topics that we will cover would be protocol buffers and what they are, what is RPC, what is gRPC, and then we're going to put it all together into the final project by building a real-world API. So, what is protocol buffers? Now, protocol buffers or protobuf is a way to define and exchange structured data. It is used in APIs, most commonly in microservices and other places. Now, you can think of it as a faster and smaller alternative to JSON. As you know, in REST API, a data exchange happens over JSON data, right? Now, protocol buffer is just an alternative to it, which is faster and smaller. Next, let's look at why protocol buffers are used. Now, first we should understand JSON. Now, JSON is in text format, and it takes a large space, and it has no strict structure. And this is where protocol buffers comes into play. It is of binary format, so the messages are much smaller and faster to process, and it follows a strong and strict schema. Let's now have a look at how protocol buffers work. The basic workflow is that we define a .proto file, and then we use a compiler which is known as the protoc compiler, and shortly we will install it. And then this proto compiler generates a code in a language of our choice. As you can see, the proto file goes through the compiler, and then it generates code in any language. So Go, Java, Python, JavaScript, Dart, you call it. Next, what is the basics of a .proto file? So right here, this much shows us what goes inside a .proto file. We start off with the syntax, and as of this time, the latest syntax is proto 3, so that's what we declare. And then we need a namespace by declaring a package. For example, package user. And then after this too, we define the structure of the data, which is known as a message. And then we give that data a name, for example, user. And inside of that, we define the fields. For example, here, string name is equals to 1, int 32, age 2. So it goes 1, 2, 3, 4, 5, like so. And so the main parts of this .proto file is a syntax, so the whole syntax, the package, the message, and the fields within a message. Now let's dive deep into this. Let's look at these messages. And like I said, a message is a structure of data. For example, like we saw in the last slide, we had a user with string name and int 32 age. Now it is very similar to a Go struct or Java class or a JSON object. Next, let's look at the fields, and fields are what goes inside of those messages. The fields describe the data inside a message, and the syntax is that we declare a type, then we give it a name, and then a number. So example, string name equals to 1, int 32 age equals to 2. Now field numbers make protobuf compact and efficient. Now something to note, these numbers should be from 1 to any number, right? You go up. You can't go below 1. So no 0 and no negative. 1 and upwards. Next, what are the field types that we have? The most common types are string, int32, int64, bool, float, double, and bytes. Next, we also have lists, and they are known as repeated. So, for example, in a message, if we want to declare a list, we say repeated, and the list of what? So list of string, so repeated string, and we give that a name of skill and then a number. We assign a number. And for example, the data in this might look like this. So we have an array or a list that has Go, Docker, and Kubernetes as strings, like we said here. Next, we can also embed maps. So protocol buffer supports key value maps as well. For example, we declare the map keyword, and then we put the data type that goes in through the map. So for the key and the value, for example, string and int32, and we give that field a name, in this case, mark, and of course, we assign a number. And the data here might look like this. So we have a map, and then the string key is math, and the int32 value is 90. Likewise, the string key here is English, and the int32 value is 80. Next, we can also embed nested messages within a message. So for example, you see here, we have a message user, and inside of that, we have another message embedded, which is address. And it has its own field, string city, string country, and so on. Next, let's look at required versus optional fields. So in Proto 3, which is the current version, all fields are optional by default, and required was removed. So now we simply just say as string name1, but before we had to say required or optional explicitly. Now, by default, all fields are optional. Next, let's look at reserved fields. So, for example, when removing fields, mark them as reserved, because you can have versioning, right? So, for example, your proto file might be used in other services. So whenever you upgrade your proto file into in a single service, you don't have to immediately upgrade in all other places. So you can just mark them as reserved, so other places still have it, but then you introduce new fields as well. And like it says, this prevents reusing old field numbers, and it is important for backward compatibility. Now, if all these things are going over your head, don't worry, all these slides were just a quick rundown, and soon we will start coding ourselves and understanding using real examples. So, up until now, we have covered what Protobuf is, how the workflow happens, the structure of a .proto file, the messages that goes inside a proto file. So we start with the syntax, then the package, then messages, the fields of the messages, the types of fields, the repeated list, messages, next nested messages, required versus optional, and reserved fields. So with all of that, next, let's install the protoc compiler. All right, now let's install the protoc compiler, which would then take our .protoc file and compile it into our target programming language. So on Google, you can just search for Protobuf, and then you will get this link, protobuf.dev. Go into it. And then on the left-hand side, you will see this protoc installation. Click onto it, and it will then point you towards a GitHub page. So let's go there. Now in here, as of this recording, the current version of protoc is version 34. And if we come down just a bit, we will see all the assets that are downloadable. Now, I'm recording this video on a Windows machine, so I'm going to download for a Windows machine. So I'm going to choose this protoc win64.zip. And actually, I already have it downloaded right here. So all we have to do is extract it, and I have also done that. So I go to my document, or maybe I go into my users and here, and let's search for develop. So I've created a new folder here, and I've named it develop. You can name it whatever you wish. And inside of that, I have this protoc, the extracted file. Now, inside of this file, you have this bin and include. And if you go to this bin and then you take this whole address, so you copy it, and then you search for env, and you go into it and into your environment variables. And then for this path, you edit, you click new, and then you add this thing here. Now I've already added it before, so I'm not going to edit it again. And then you OK it. Likewise, you go for this path, edit, new, and add it. And then OK, OK out of it, and OK out of this one. And to check if the installation is working, I'll go to this command prompt, and I'm simply going to write protoc. And if I hit enter, I get to see an output and no error, which means the installation is successful and Windows recognizes this protoc compiler or executable properly. Now, if you are on any other operating system, feel free to take help of an AI to show you how to configure it. All right. After installing the protoc compiler, what's important is to install the protoc-gen package. So on Google, let's search for grpc and then head to this grpc.io. Now in here, I'm going to choose Go because that is the language of our target. And inside of this, we get to see some prerequisites. And here we should have Go installed. For me, that is the case. And then in the last lecture, we installed the Protobuf compiler, so protoc together already. And all that's left is now to install this plugin. So I'm going to take this command, I'm going to copy it, and I'm going to open up my command prompt, and there I'm going to paste it, like so. And this should be fairly quick. So it seems like it's done. So what I'm going to now do is check if the installation was successful. So I'm going to search for protoc-gen-go and then space / version. Actually, I think here I should also add -grpc. Correct. And then I get to see the installed version with no error. So the installation of this plugin was successful. Now, before practicing protocol buffers, let's install an extension for VS Code. So I'm going to go to this extensions tab, and I'm going to search for Protobuf. And then here, this Protobuf package, so protocol buffers by pbkit is what I want. So I'm going to install it. And give it a few seconds, and that's done. So with this extension now at hand, and also the protoc compiler and the plugin, in the next video, let's start the practice. All right, let's get started, and let's get started easy. I'm going to create a new folder into my project root directory, and I'm going to name it proto. And inside of this proto, I will have all the source proto files and then the generated Go proto files. And the first file I'm going to create would be main.proto, but feel free to name it whatever you want as long as the extension remains as .proto. Now the procedure is that we start off by declaring the syntax. And for our case, the syntax is syntax equals to, in double quotes, proto3. So this is the latest syntax, proto3. And we must remember every line must end with the semicolon. Next, we need to declare a namespace, so a package declaration. And I'm going to name it package main, and then of course we will need the semicolon, like I said. So those were the two things. And then the third thing is a message. Now we know message is just a data structure. For example, structs in Golang. In Protofile, such structs are known as message. And I'm going to create this message with this message keyword, and I'm going to name it hello request. And this data structure will have two fields. And we know fields are just fields of a struct, right? And first we give it a data type, and in this case I'm going to start with a string, and I'll give it a name of name, and then a field number, and I'm going to start at 1. So it's not the value, but it's the number of this field. And also an age, maybe int 32, and the field number here is 2. So the age is not 2, the field number is 2. So that makes the message data structure or message data, you could say. I'll also create one other message, and I'm going to name it hello response. And in this, I'm going to have a string, and I'll name it conf. So confirmation message, conf underscore message. And because this is a separate message, I'm going to start here again at 1. So that's that. That is how we write a basic proto file. Now to generate this proto file, what I want is inside of this proto folder, I will have gen folder, and inside of this gen, I will have generated files. Now to generate a file, we need to declare a target here in this proto file. So a target where this file should be generated. So after this package, I'm going to declare an option. And this option would be go underscore package, and this would be equals to, and then in double quotes, I need to write a few things. So the first thing is that it should target slash proto. So this slash proto and their slash gen. And inside of that, the Go file that would be generated. So from this proto file, we want to generate a Go file. And that Go file will have a package declaration of gen pb. So gen protobuf. And that's all. Now we should open our terminal, and in here we're going to execute a command so we can generate the file. Now to execute this command, we're going to call that protoc compiler that we installed a few minutes ago. And here I want to pass a flag using this dash capital I. And then the value here would be proto. So this means the starting point is proto. And then after a space, double dash, go underscore out. So now I'm saying to output go, in go, and this is equals to dot. So right here. So right here, which file? So the file that is inside proto and there slash main dot proto. And a good thing is to copy it out, to copy this command out. And actually save this command inside of this proto. I'm going to create a command.txt, and I'm just going to save those commands here so I can execute them again in the future without writing them. Anyways, let's execute this. And I get to see age is not defined for some reason. So let's try again. It says oh, my bad. This data type should be in front followed by the name. So yeah, with that, let's generate this again. And as we can see, the main.pb.go was indeed generated. And as you can see, this is a regular Go file, and it has our hello struct with age and name, and also some private fields which are not to be used by us. Also, we get to see this reset method, and this is a method because there is this struct embedded here, right? And these methods are never to be used by us, they are to be used internally. So that is how you write a basic proto file and then you execute it with the target. Let's create another proto file just to practice things. So I'm going to remove all, and inside of this proto, I'm going to create a new folder, and this would be user. And inside of this user, I'm going to create user.proto. All right? Like so. And we know we start off with our syntax, which is equals to proto3, and we end it with the semicolon. Now we should also declare a package, so a namespace here, and I'm going to name it package user. And of course, we end it with a semicolon. And before declaring a message, so a data structure, I'm also going to add the option. And the option gets go underscore package, and this is equals to the package name I want, but two things goes in here, the target destination and then the package name. So slash proto slash gen, and then using a semicolon inside, I'm going to then add the gen-pb package name, and I'm going to end this entire sentence, so that is this entire statement with another semicolon. Now, the reason that I'm also naming this gen-pb and that main also got the gen-pb, so both generated files are to be under gen-pb package because both the generated files are going here inside this gen folder. And we know in Go language, all the files under one single folder gets the same package name. And that's because this main.pb ends with .go, so that's a Go package, Go file. And the user.proto that we will generate soon will also be a Go file, right? Generated files are all Go because we're targeting it to Go. All right, so that was the start of this user.proto. Next, let's make a message. And I'm going to make this user data type, right? Data structure. And the only field here would be a string of ID. And the value here, not the value, the field number is 1. So with that, now we can execute this. We have that protoc-i equals to proto, and then -go-out dot, and then instead of this proto slash main.proto, we want to go to proto slash user slash user.proto. And I'm also going to grab this entire thing and then execute it. And as you can see here, inside of this gem, I now have this user.pb.go. So the generated file under the Go language. And before I end this lecture, I'm also going to add that command right here. Next, let's learn how to import one protofile's things into another protofile. So up until now, we created two protofiles and we have generated them. So main.proto and then user.proto. Now I want to create order.proto. And instead of this proto, like this user, I'm going to create a new folder. And that would be order. And inside of this order, I will have order.proto. Now you can have it without this folder, so just alongside this main. So after this main, you have user and order. You can do that. I'm just doing it to group things together. That's it. Nothing special. Anyways, so in this order.proto, let's start by saying syntax is equals to, in double quotes, proto3, and then we end it with the semicolon. Next, we will add our package declaration, and the package name would be then order, and of course we end it with another semicolon. Now, like before, I'm also going to add this target option. So option gets go underscore package, and this is equals to in double quotes. And two things goes in here. So the target destination, which is slash proto slash gen, and then inside of this double quotes, separated by a semicolon, we declared the package name for the generated file, which is gen-pb in this case. Now, in this order.proto, I want a message, which would be named as order. And I'll keep things simple. I'll add a string ID, and the field number here is 1. And then I want to access the user, so the user that I have here. So that would be instead of the user package, and so instead of the user package, we enter dot the user message, so this one, and we give it a name of user and then the field number, which in this case is 2. Now for this user.user to work, we need to import it. And the best place to write the import statement is between this package and this target option. So right in between. So I'm going to import it here. So import, and then in double quotes, I want to enter the user package slash there the user.proto. And of course, I have to end it with this semicolon. Now, let's see if we can execute this. So we want to call protoc that flag, which is -i equals to proto, and then that --go underscore out equals to dot, and then proto /order dot proto, right? Like so. And I'm also just going to grab this all and I'll paste it right here. So with that, let's execute this command. And I have a mistake, so it should be package, right? So let's clear this terminal and let's run this command again. And our order.pb.go was created. And we also learned how to import contents of one proto file into another one. While we are at it, let's also see how to nest data together. So nested message, how does that work? For example, an order should also have a message, an address of the delivery, right? So for example, we create a message and we name it address. And inside of this, for example, we have a string area and this gets a field number of 1. And then this address is what I want for this order, inside of this order. So I have this address type because that's a data type here, which is a message. And I'm going to name it as address. And then this gets the field number of 3. So that is then how nested messages work. Now, to bring this Protobuf practice to an end, let's also learn what services are. You see, inside of a proto file, two super important part is a message, so which is a data structure, and then service. Service simply means what can be performed with those data structures. So how does a request come in? How does a response go? What operations can be performed? All those are services. Just how all data structures are messages, all operations are services. So how does a service work? For example, we write a service by writing this service keyword, just like that message, we write the service, followed by the name of the service. For example, example service. And inside of this service, then, we will have method declaration. For example, an RPC call, and I will teach you what RPC is and then what the framework gRPC is later on. But for now, bear with me, everything will click together, everything will make sense as we progress. So we're creating a service which we named example service, and in this we want a RPC call, and we can name it, for example, say hello. And the idea is the request would come as the hello request. All right. And then after it came to us, after we process it, it's going to return the hello response. And we end it by a semicolon. So that is the syntax. So we create this example service using the service keyword. And inside of this, we can have multiple calls like so. And other than this, we can also import our user.proto and the order.proto just to see an example. So as I told you, it goes between package and option. I'm going to import both of them. So I'm going to import user and there the user.proto. I'm also going to import order. I'm going to access order and there the order.proto. And I'm doing this, for example, inside of my service example service, other than this RPC call, I have another RPC call, for example, RPC, like so. And the name of this call is get user order. For example, yeah, I want to get a order of a user or get user. Let's just stick with get user order. So this call should bring details of a user or at least an ID, something, right? So how do we work with that? We access the user package and they're the user. And then I'm going to return. So it returns. Inside of that order package, we can access the order. like so. Now, of course, in real life, and as we progress, things are going to be much larger than this, but this is a bird's eye view. So now we know about messages and we also know about services. And inside of the service, we can have many service call, or we can also have more services like this with their own particular calls or execution calls. Now, to end this proto practice, what I'm going to do is going to show you something. I'm going to remove all this gen together. And if I come to this command, I have all these commands, right? I can combine all of them. So for example, let me grab one of this. So it has that protoc and then that flag and then output and then the main file. I can also add this user file after this and also this order file at the end. So 3 files to be generated. And I can grab this command and add this here to come to this terminal and execute it. And in this gen, you then see all those 3 files were generated. By the way, in this main.pb, we should also now have some sort of pointer to that service. Hello, say hello, get user order, and all those things. One last thing that we should also discuss before diving into RPC and gRPC is what are these services? So you see inside of this service, we have encapsulated methods. And these methods are, in the end, remote calls, all right? Remote function calls. So that is a service, something that we write ourselves in a .proto file. So that's a service. And then we use the protoc compiler to generate a Go file from this proto file. And in that proto file, the thing that gets generated for this service would be a stub. All right. Now with that, let's have a look at the presentation. So at the end, a service defines the RPC method, just like one of these, in a .proto file. For example, the service, example service or order service, and there the RPC get order. And it tells us what methods exist. We can have a look at what are the methods that exist inside of it, what requests they take, what are the parameters that goes inside of them, and what type of response do they return us. And the server implements this service. Next, what are stubs? Now, a stub is the generated code, like I said. The service, after you generate it, what gets generated is the stub. And this is a code that allows the client to call a remote service, like a local function. It is automatically created from the .proto file, and that is the whole idea. So basically, the client calls the stub, it goes over the network to the server, and then in the server, we call the appropriate service, which in this case is client.getOrder. The stub handles request serialization, sending the request, receiving the response. So in summary, stub is just auto-generated client code for calling remote RPC methods or services. And so, just to recap, .protoc file has the service defined and the protoc compiler generates the stub from the service. With Protobuf now under our belt, we can now safely move towards understanding RPC, gRPC, and things that goes inside this gRPC. So let's start by talking what is RPC and what is gRPC. Now, RPC stands for Remote Procedure Call, and it is the idea that allows a program to call a function on another machine, so in a far away remote machine, as if it was local function. All right, so for example, I'm calling a function within my program, but in reality the function is actually invoking something in a remote computer. That's the idea of RPC. So behind the scene, it's like I click this get user order service, the service that we created back when understanding Protobuf. And what happens is when I call that function, the client sends a request to the server, and then the server responses back to the client. That is what happens, just like a REST API call. Now, the RPC framework handles network communication, data serialization, sending requests, and receiving response. So, like I said, this RPC is the idea. This is not anything, it's just an idea of how things could work. And framework means the implementation of the idea, which is gRPC. So, next, let's go to gRPC. Now, gRPC is a modern RPC framework developed by Google. So, on one hand, RPC was the idea, and then gRPC is the implementation of that idea, right? Now, it uses protocol buffers, something that we have learned up until this point, for APIs and messages and services and all those things. It uses HTTP2 for communication, and it generates codes for clients and servers in an idiomatic and non-error way. Now, the benefits are that it is extremely fast, both to transmit and process. It is strongly typed, and so things doesn't often go wrong, and it has support for multiple programming languages. Now, other than this, gRPC also has a lot of other things which we will dive into step by step in small steps. And because we're learning everything from the ground up, from scratch, there will be quite some theory to cover alongside practical examples. And so, the summary of RPC and gRPC would be that RPC is the concept and gRPC is Google's implementation of that concept. Let's have a look at traditional REST API versus gRPC implementation. So REST uses 1.1 HTTP and gRPC uses HTTP2. Now HTTP2 has many advantages over HTTP 1.1 and we will learn about them step by step. Now the data format that is used in REST is JSON, which is a text-based format, and in gRPC we use protocol buffers, so something that we have learned up until now. Now, in terms of speed, gRPC is way faster than as compared to REST, and it is also smaller. The API style for writing things is that in REST we use this URL-based resource, and in gRPC we use function-based API calling. Now, the streaming capability in REST is very little because in REST it's you send a request, the server sends you a response back, and done, it's done. If you want any sort of streaming, so continuous connection in REST, you need to use WebSocket. On the other hand, in gRPC, such capabilities are built in. Also, the type safety in a REST environment is very weak because you can write a URL call and then you send the URL and you won't get the error until it is ran, so in the runtime, and there is some validation done, right? But in gRPC, because you define a solid function beforehand, so when you write your function call, the function will tell you these are the things I need in order to be executed. So that's a bird's eye view of REST versus gRPC. Time to practice gRPC. And I have created this gRPC practice folder to contain two Go modules, one server and the other one is client. And we're going to start with the server. So let's create a server folder here. And I want to go inside that CD server. And instead of this, I'm going to initialize a Go module. So Go mod init, and I'm going to name it server. Like so. Now inside of this server, I have to actually install a package. So you can search for protoc-gen-go-grpc, and that would be this right here. Go install google.com.org/grpc/cmd/protoc-gen-go-grpc latest. And I'm going to install it in with this command prompt, and this is a system-wide installation. So let's do that. And I can then check the version of it to see if it was installed properly, which it did. The next thing is to install a package for this module, And for that, you can search for google.golang.org/grpc. So this is the thing we want. And back in our server terminal, I'm going to do go space get space that name. There we go. Now, inside of our server, I'm going to create a folder for our proto. And inside of this proto, I'll have a main.proto. Now, our server and client, it's going to be super simple for practice, and it's going to be a calculated thing. So we send two numbers from the client to the server, and the server is going to add them and send it back to the client, all right? So for the server, in the proto file, we start off with syntax, and that is proto3. And of course, we need to end every line with semicolon. We need to declare a package, which I'll name as calculator. And then we also have to set an option, which is go underscore package. And here, two values go in. The first value is the location, which is /proto/gen, and then separate with a semicolon the name of the generated package, which would be genpb, like so. And then the service to be carried out gets this service keyword, and I'm going to name it calculator with a capital C. And inside of this, I'm going to declare an RPC method. So RPC method, which I'll name as add, and make sure the A is capital so it can be used from the Go file when we implement it. And it's going to take an add request, and then it is going to return using returns add response. Now all we have to do is create two messages, one for add request and one for add response. So message add request, it's going to take two integers, so int 32s, and I'll name the first one as A, caps, so we can use it from outside, and the field number here is 1. 1 is not the value, but the field number. Please keep that in mind. And the second one is another int32, which I'll name B, and sorry, it's just equals to 2 here as well. So that was for the add request. Next, we need another message for add response. And this is going to be another int32, which is going to be sum, like so, capital S, and this gets the field number of 1 because it's a separate message. So with that, our main.proto file is ready for the server. All we have to do is generate it. Now, how do we generate it? Well, we will run a command, protoc, and dash capital I, and this would be equals to proto. So this pointing to this folder, proto, and then space, I need to call dash dash go underscore out, which is equals to dot. This should be underscore. And additionally, one more, that would be dash dash go dash grpc underscore out, which is again equals to dot. And then the file to be generated, which is this proto slash main.proto. And I'm just going to grab this command out of it. Now you see, we get a gen, and this time we get two generated outputs because we're using two flags right here. And the first one, main.pb.go, contains the messages and all its fields, while the main underscore grpc.pb.go contains the services. So with the generation ready, instead of this proto, I'm also going to make a command.txt just so I can save this command. Anyways, it's time that we implement it and create our server. So inside of our server, I'm going to create a main.go outside of that proto, but inside of our server module. And let's work on this. So what do? Well, in a Go file, first we mention the package, and this is package main, and then we will need our function main. So the entry point to our Go program. And first we need to open up a port in our computer, which we will then plug to the server we are going to create so the server can listen through the port. And let's create a port variable for that. And this will be all string. And the port number is 50,051. You can use any port number, but the convention for gRPC is that you use something along 50,000. Next, let's listen to a port, right? So we're going to call net package. And on that, we have the listen method. And we want to listen using TCP, not UDP. And we're using TCP because TCP is inherently streamable, and so is gRPC. So TCP is the connection choice for us, followed by the port number, which is inside that port variable. Then this listen gives us a listener and an error. So let's grab those, listen and error. And both of them are new variables. And first let's handle the error. So if error is not equals to nil, what do? Well, I want to call log.fatalf, log.fatal. And inside of this, I'm going to say fail to listen, and I'm going to then pass the error to it, like so. But with that, next, let's create a gRPC server, which we will then plug to this port. So we're going to call the gRPC package that we installed, and on that, we're going to call new server, not new client, but new server. And this new server then gives us the gRPC server. So let's add the gRPC server like so. Next, let's plug this gRPC server to this port. And before we do so, I'm going to add a comment here, and I'm just going to say to do because there is something we will do right here. Anyways, let's plug that in. So I'm going to call the gRPC server, and on that I'm going to serve using that listener that we got for the port, like so. Now this then gives us another error which we should handle, and I'm going to bring this, and I'm going to say log.fatal, and I'm going to say fail to serve, and then pass the error. By the way, when the server runs, I also want to log a print line, so I'm going to use log.println, and in here I'm going to say server is running on port, and I'm going to come outside and pass the port right here. So this is how the server runs. So let's try it out. So we are already in the server. I can just do go run main.go. And if we do that, and I allow this, we get to see our server is running. So congratulations, pat yourself on the back. But it was a bare bone for writing any Go server. Let's expand the functionality now. So what do we want? Well, we want to make sure that our server can accept request and process it and send a response back, right? So what I'm going to do is first we need to create a server struct. So I'm going to create type server, and this is a struct. And inside of this, I need to call the calculate server, so the unimplemented calculate server. Now, what is this unimplemented calculate server? Inside of this protogen, if I go and search for unimplemented server, we get to see it right here that all implementations must embed this unimplemented calculator server. So that is what we need to implement first. And we can access that using the genpb package, right? Yep, genpb. So I'm just going to add an alias to it, pb, and the path here would be starting with our package module name, which is server slash, I think we need to go inside proto/gen, like so. And then using this pb, we can access pb dot unimplemented calculator server, this one. Well, with this now, we can access the add method right here. So outside of that server struct, I'm going to make a function, and this function has to be a pointer receiver of this server struct. So we're going to add the s, which is a pointer to this server, and I'm going to name it the same as add, as we did in this RPC method. And this add then takes what? Let's go back to that main grpc pb.go, and if we come down just a bit, we get to see this add. And this takes a context and the pointer to add request and some options, which we don't need to care about at this moment. So let's give it all those things. It needs a context, which is a context. Now we have two contexts here. One is context from context of the standard library, and another is context from GenProto. We want the one from the standard library. So context.context right here. And the second argument is a request, which is a pointer to that pb alias, and there the add request. And this function also has a return type, which is a pointer to the add response and an error. So we use the pointer to pb dot add response and an error. Now what do we do in the function body? Well, we want to return a pointer to this add response. So in the function body, we're going to call the ampersand, and we want to access pb.addResponse. And in here, we need to pass a sum. And the sum is going to be the request, the incoming request. So request, and there the A, plus request, there the B, both of these fields. And additionally, with this add response, we should also pass nil for the error, just like that. Now this sum right here, I'm going to extract it outside. I'm going to say sum colon equals to this right here, and this sum comes right in here, like so. And here I'm also going to add a log.print line, and I'm going to say sum, and then I'll pass this sum right here. So we get an output when the client makes a successful request. So with that, we now have our server ready, and we also have this add function as the pointer receiver of the server struct. All we have to do is make sure that we use it in our main function, because that is where everything executes. So let's do that. After we create this server and before we start listening, here we need to implement it. So I'm just going to access the PB, and there the register calculator server. We need to call this, and this register calculator server is coming from this main.grpc.pb.go right here. And you can read it all, that we must use it in order to use that add implementation. And by the way, this register calculate server takes a grpc service registrar and a server. Now this server is the server that we have already created, and this register is something we have already. So the grpc server, which is right here. So to that pb.register calculator server, we are first going to pass the grpc server that we created right inside of the main function. And then as the second argument, we're going to pass a pointer to this server struct. So we're going to do ampersand and the server struct, just like that. And with that, we are now pretty much good to go. So let's save it. And that was all for our server. By the way, let's run this as well, just to see if we get any error. And we don't. So everything is running well. In the next lecture, let's implement a client that would request this server with 2 numbers to get a response back. With our server now up and running, it's time that we create a client that would connect to this server and finish our first basic project. So the idea is that alongside this server, within our project, I'm going to create a new folder for client. And this is a new Go module. And I'm also going to create a new terminal. And I'm going to go into that client. And I'm going to create a Go mod here. So Go mod init, and I'll just name it client. Now we need to install a package level, a module level package in here, which is this one, google.golang.org/grpc. Now it's only this one, not the other package. Please remember, this package is a system-wide package, not a project level package, while this one is our project level package. So let's install it. And we are going to install it because we are going to create the client using Golang. If you would be using some other language, we would use some other package here, not Golang specific package. So go get that one. All right, we already have this. Now the thing is, we need the proto from the server to inside of this client. So I'm going to reveal this in File Explorer. And I'm going to go inside of that server and I'm going to grab this proto and add it to our client. Because in a real world, you would share your proto file of the server with your client. And your client can be anything. Your client can be a mobile app using Dart, maybe Swift, maybe JavaScript, maybe Java, maybe Kotlin, or it can also be a web app using JavaScript, right? So you share the proto file with them, and then they generate the generated file from the proto by themselves. Because this main.proto is language agnostic, so you can generate code for many different languages from this proto file, not just Go. But because we are using Go, we can stick to this generated file that we have. By the way, let me just simulate the real world scenario. So I'm going to delete this. And we are going to generate the gen folder from this proto inside of this client again, simulating real world. So I'm going to use this command, and we are going to use this command because we're using Go. If you would be using some other language, you would change these flags. And I need to make sure that I'm inside of client. So let's run this program. And again, for the client, we have our gen. Now let's create the client. Inside of this client, I'm going to create another main.go. And we should start with package main, then a function main. Now this main for the client, it's going to be much simpler because there is no implementation to be made. Just we're going to call the server from this client. So what do we do? Well, the first thing is to call the grpc that we just installed, and there create a new client. And this new client needs the domain address of the server, which we know for our case is localhost and the port number is 50,051. So what I'm going to do is here, I'm going to make addr, and this will be a string, and it would be localhost and colon 50051, like so. And then this address is what I want to use here. If I hover on this client, you see I get the target, so the address. And I need to pass some options, which we will leave for the moment. So then this right here, this client gives us a connection, and it gives us an error. So I get a connection and an error, like so. Let's handle the error first. So if error is not equals to nil, what do we do? Well, I want to call log.fatal line. And in here, I'm going to pass did not connect. And then I'm going to pass the error right here. By the way, this fatal line is also something I want to use for the main of the server. Right here. Also here. Anyways, So with that, we're handling the error, and if there is no error, we will have a successful connection. And when this main function ends, we should also close this connection. So I'm going to call differ, and on the connection, I'm going to call close, like so. But then what if we have a proper connection? What do we do? Well, I want to first of all run this client and see what's up. So I'm going to do go space run space main.go, and let's hit enter. And we have an error. The error is because gRPC uses HTTP2, and HTTP2 requires some security, right? It requires TLS. And because we are now developing, I don't want to mess with TLS at this moment. For this new client, I'm going to pass an option saying that I don't want to pass any TLS at the moment. And this error message is helpful enough to say what we should use if we don't want to use TLS at this moment. So I'm just going to grab this entire thing, and I'm going to add it here after a comma, like so. And to bring this insecure, I can just save it, and I get that insecure from the gRPC right here. So with that, let's run our server again and see what happens. And it is running. So let's move forward. What I'm going to do is, after a successful connection, after the differ call, I'm going to call our genpb, and on the genpb, we will have a new calculate client. Just like in the server, we had a server implementation for the client. Instead of this gen, we will have a new client calculator client right here. So this is what we need to call in order to access the add request and everything. So right in here, what do we do? Well, I want to access the PB, so I'm going to make another PB right here. And we access it by calling our package name, which is client, client slash proto slash gen. Oh, my bad. So PB, and we access client module, and they're the proto package, and they're the gen package. So using this PB, we can now call new calculator client, right? Right, this, and this new calculator client requires a connection. So client connection interface, which is this right here. So we will pass this connection to this. And with that, this then gives us a client, a proper client, which I'm going to save in this variable. Next, we can use this client to call the RPC method. So what I'm going to do is, on that client, I'm going to call this add method. Now this add requires a context and a few other things. Now to not write the context right in here, I'm going to write it in a separate line. So I'm going to call a context, and I'm going to create a context by accessing the context package, not the gRPC, but the standard library context, and there the context with timeout, like so. And on this with timeout, I need to pass context.background and a timeout. So I'm going to give 5 seconds, 5 multiplied by time dot second, like so. And when this main function ends, I also want to cancel this context. So I get the ctx here and also the cancel function. And here I'm going to differ call this cancel. But anyways, let's pass the context to it. And we should also then, if we hover over this, and we have this pointer to the pb.add request. That is something we need. So we can add this right here, but to not mess it up, I'm going to add it in a separate line. So I'm going to make a response and an error, and we get that. Sorry. And we get that when we access the client. Sorry, not like this. I'm going to make a request variable, and this request variable would be the PB and there the add request. And on this add request struct, I need to pass two fields. The first one is A, and I want to pass 10 for this, and the second one is B, and I'll pass 20 for this. So I want to send 10 and 20, and I expect 30 back, right? And this request is what I'm going to pass to this client. So client.add, to this we pass a context and a pointer to the request that we just created. So this add then would give us the response and an error. So we are going to get response and an error, like so. Let's handle the error first of all. So I'm going to do if error is not equals to nil, I want to do log.fatal line, and in here I'm going to say could could not add, and I'm going to pass the error. But if we don't have an error, I'm going to print out the response by using log.println, and in here I'm going to say the sum is the response, and on the response we get the sum, because please remember this response is a add response, and on that add response we have a sum field right here. So that is what we are printing out. So with that, let's now run this client and see what's up. Make sure the server is running beforehand, which it is, and now let's run the client. And there we go. We successfully get our response back. We sent 10 and 20. If we go to the server, you see, we added it and then we sent it to the client. And in the client, then we are printing it. So that is a simple implementation of a client and a server using gRPC. So in the last video of the client, right, we use this gRPC with transport credential, and there we set it to an insecure credential, right? It's time that we change it, because in the real world, you want your connection from the client to the server to be encrypted, and we're going to use TLS for that. Now, to use this TLS secure connection, we need a certificate and a key, and these are things that you can get from reputed source. However, because we are currently in development, we are going to self-signed generate it. Now, the command to generate such certificate and key can be found inside the server command txt, and you can get it through the GitHub description and GitHub link, and then this is the command you need. However, when you execute this command, you might face an error. And if you do face an error, take the error message, including the command, and give it to an AI. And the AI will give you your operating system specific solution. The other thing is, inside of our server, this is where we're going to execute this command. We will also need a cert.conf file here, cert.conf. So it's just some configuration for the certificate that we want to generate. Because without this, you would have to write all these things manually when you want to generate the certificate. But with this, all this data is right in here, and when your certificate expires, you can generate a new certificate with all this old data, right? As you can see in this command, this certificate will only be valid for 365 days. So pause the video here and copy it out or grab it from the GitHub. So next, let's execute this command. And as soon as I execute it on the server, I get this cert.pem and key.pem. Now this key.pem should only stay in this server, but this cert.pem, I'm going to copy it and also paste it inside my client. So my client can also use that certificate. However, please remember the key.pem must only stay within the server. So with that, let's start by configuring our main.go of the server. to handle the certificate and key, and later we will also configure our client to send the certificate. Let's start with the server. Now I'm going to create two variables instead of the main. That would be cert, and the value here would be in double quotes, cert.pem, and this directly points to the cert.pem because this file is right beside this main.go. And then we will also need a key variable, and as you can probably already guess, this would be pointing to the key.pem, like so. And now both of these are what we want to use. So where do you want to use it? Just a moment. What's wrong? Right. So with that, I now want to create some credential, because in this new server, if I hover over this, you see it takes some option and I can go into that option. Well, I cannot for some reason. Anyways, so here I want to pass some option, and the option would be credential options. But first I want to generate such credentials. So right above this gRPC server, I'm going to call credentials from the golang/grpc/credential. And on this credentials, I'm going to access new. If I could only get the suggestions working. Yeah. New server TLS. It's very important to choose server TLS, not the client TLS, because we are now in the server. So new server TLS from file, like so. And then to this, we are going to pass the pointer to our cert and key. And then this method then yields us credentials and error. So creds and error. And let's handle the error first. If error is not equals to nil, I want to call fmt.fatalf or fatal line. And here I'm going to say fail to load credentials, and then pass the error, like so. Oh, this should be log.fatal line, like so. And with that, we now have our credential ready, and this is what I now want to pass to this new server. So in here, we need to access the gRPC package again. So gRPC, on that we have the creds, this one, and to this we pass that credential, and that's it. With that, our server is now ready to accept certificates. So let's run our server. I'm going to say go run main.go. And with that, our server is now running. Now let's go to the terminal of our client and also go to the client main.go. And we have already brought the cert.pem already to this client, just beside the main.go. And inside of this main function of the client, we again create the cert variable pointing to the cert.pem file. And then what do we do? Well, it's pretty easy. We just want to access the gRPC again, and they're the new client. Sorry. We want to access credentials from golang/grpc/credentials. And on that, we want to access new client from file, new client TLS from file. And this time it's client, not server, because we are now working with the client. And to this, we pass the cert. And for the key, we're going to keep it empty because there is no key. Key stays in the server. So this method then gives us the credentials and error. So I grab both of them, creds and error. And I'm going to handle this error. So I'm just going to grab this this error handling and paste it right here. And I'm going to say, I'm going to keep it the same. So with that, we now have our creds, and this is what we want to use here instead of this insecure new credentials. So In here, instead of this insecure.new credential, I'm going to pass that creds like so. And with that, we are now ready. Let's now run this client. So main run, go run main.go, and we get our result back. And now we're using an encrypted secure connection over using TLS. I quickly want to show you a trick. That is, let's say our server, gRPC server is running, which it is. And in our client, maybe we don't want to send any request. We just want to check if the server is running from the client. We can do that. So I'm just going to comment all of this out. So none of this is working, right? So no request should be sent. We just set up our client with the certificate. Also, you can do it without the certificate if you want. And in here, I am going to check the state of the connection. So con.getState, and then this gives me the state. Maybe I can say con state. And then I can do fmt.println. And in here, I'm going to say connection state, and then pass the const state right here. So with that, let's run this client. We know our server is already running, so I'm just going to run this client. And we get to see that the connection is idle, so it means the server is running. All right, let's now add a new proto file and a new request response cycle. And I'm going to start with the server. So instead of my server, right here, instead of the proto, I'm going to create a new proto file. And I can name it greeter. Greeter.proto could be the name. And instead of this greeter.proto, let's start with the procedure. So I declared the syntax first of all, which is going to be proto3. And of course, I have to end it with a semicolon. And then I need to also give it a package. So package. And because this greeter is in the same line or next to main.proto, both of them should get the same package name. So let's check what's the package name in main. It's calculator, and then this should be also the calculator. But if instead of this proto, I would have a separate folder to contain this greeter proto, then the package for greeter would be the name of the folder, right? So anyways, next, I also need to declare option, and this would be go underscore package. And this is equals to two items. First, the destination, which is /proto/gen, and then inside of this double quotes, separated by a semicolon, the name of the generated package. In this case, I'm going to name it genpb. That's the name I like. Now next, I want to create a service and two messages. So the service would be a greeter service, greeter. And in this, I will have one method, one RPC method. The name of the method would be greet, and the method comes with a hello request. And then it returns hello response, like so. So now with that, because we have a hello request and a hello response, we need to create two messages describing those hello request and hello response as a data structure, right? So message, and this is the hello request message. And what does it contain? Well, it's going to contain, you could say, a string which gets a name of name, and the field value is 1. Not the value of name, but the field value is 1. Number of field is 1. And then again, message hello response. By the way, let me check in main.proto. Do I have? No, there is no hello. Okay. And here I'm going to say string message, and this is again another one. So with that, we now have a proto file inside of our server. Oh, yeah. Inside of inside of our server, and we now want to execute it. So I'm just going to, I can keep this gen file, but I can also remove it. But anyways, let's just keep it. I'll open the command txt, and this command now should be extended, and I should also add proto slash greeter.proto, like so. So I'm just going to grab it, and I'm going to go to cd server and run this. Now, you see inside of the gen, I now have the greeter grpc pb.go, also greeter pb.go, and I have this both for both of the proto files, right? Now, something to note, in your proto file, if you don't have a service, the underscore grpc file will not be generated. So, in other words, underscore grpc file only gets generated when you have service mentioned inside your proto file. All right. So that was our proto file, and then we generated the proto file. All that's good. Now we should also configure the main.go of our server to handle everything, right? And this greet RPC method should also be implemented all alongside the unimplemented service, and also we have to register it. So 3 things to do, right? Each time you create a new service in the main.go and there in the server struct, you have to implement the unimplemented service server. In this case, it will be unimplemented greeter server. And then all the methods inside of the services, for us, it's just the greet. So I have to also implement that. And instead of the main function, I have to register that server as well. So let's work on those. So in here, I'm going to first write pb.unimplemented greeter server. That's one thing. The second thing is to register it. So in here, I'm going to access pb.register greeter server, and inside of this it gets the grpc server and the server struct, so pointer to the server struct, like so. And the last thing to do is to implement the function, the greet function, so the greet rpc method. So what would that look like? I think I'll keep it simple, and of course this will be a pointer receiver to the server struct. So I have to actually, I can just get this whole thing, and I'm going to name it greet, the same as this one, like so. But instead of this function, this now gets the context, of course, and for the request, it gets the hello request. And it returns the hello response, like so. And inside of this, what do I do? Well, of course, I have to return a pointer to hello response alongside nil for the error. And I'm just going to remove this too. And the hello response, if I remember correctly, took a message. And the request came with a name. So I think we can use both of them. So I'm just going to access the message that I need here. And instead of this, I'm going to use fmt.sprintf. And for the sprintf, I'm going to say hello. And I'm going to pass a placeholder, so percent maybe s. And then I can say nice to meet you. And then maybe I can say, maybe just come outside of this and also pass the rec.name. Yeah, just like that. So with that, our server is now ready. All we have to do is also generate, we have to copy this greeter.proto into our server client and also generate it there for the client specific language. Unfortunately for us, it happens to be Go. So I'm going to rebuild this in File Explorer, and I'm going to come to this proto, and I'm going to just grab it all. And actually, I'm also going to run this server. So go run dot. And in a new terminal, I'm going to go to cd client, like so. And now let's open up client. I'm also going to reveal it in File Explorer, and I'm going to add this new proto file. And I don't want to generate it again, but you can generate it if you want. We already have it generated. So what do we do now for the client? Well, it's pretty simple. I want to first say that for client, it's pretty easy. And whenever you have a new service, you need to create a new client like so. All right. So I'm just going to bring this context first so I can group things together. So this client and its request and response and the log is together like so. And then for the next service, the next client, I'm going to group them together. All right. So what I'm going to do is I'm going to change the name of this client, rename symbol, and I'm going to name it add client. And for this one, I'm going to say add request. And this one gets add response. So things are super clear now. So that's one thing. And I'm also going to add a comment here just so it's visibly clear that we have separate clients in between them. And now let's start with our new service. So I'm going to add a new client and I'm going to access the PB because imagine we have already generated everything. And they're the new greeter client, of course. And on this, we need to pass the connection. That's the first thing. So this then gives us a new connection. So a new client. And I'm going to name it greeter client, like so. Yep. And after that, we have to create a new request. So I'm going to name it greeter rec, all right? Greeter request. And what is this equals to? My bad, I have a keyboard issue. So that would be equals to PB, and they're the hello request, right? And actually, this should be a pointer. Also here, this should be a pointer, like so. And in here, I can then pass the name, and maybe the name is, I don't know, Angel, let's say. So with that, we now have our request. It's time that we send it and expect a response. So to send a request, we're going to access our greeter client. And on that, we can then access this greet method. All right. Now to this, we pass the context and we pass the request. So greet request, this is what it goes. And we get the error and response back. So greeter res and error, like so. And let me handle the error from here. And I can say could not greet. And to end this, I'm also going to bring a log.println. And I'm going to say greet, and this is a greetRes.message, like so. So with that, let's run our client, go run dot. And there we go. We get our old request response and also the new one. Now let's move on to streaming in gRPC. And streaming is the concept of two clients or a client and a server in a persistent connection, or maybe getting a stream of data as opposed to getting a whole set of data when they are completely ready. So getting chunks of data in a stream. You can say it's comparatively similar to WebSockets. And there are a few different types of streaming with gRPC: server-side streaming, client-side streaming, and bidirectional streaming. And these are heavily used for real-time applications. So with that, let's now move on and see how to implement streaming with gRPC. So let's implement a server-side stream. And in here, I have a new folder, gRPC stream, and inside of this, I'm going to start from scratch by initializing a new Go module. So Go mod init, and I'm going to name it streams. So there we go. Next, I need to install a package for Go gRPC, and I can do that using go space get, and it comes from google.golang.org/grpc. There we have it. The next thing is I now need to create a proto folder to contain our proto file, and then we want to generate everything out of it. So let's make a proto file. And in this proto file, I'm going to make main.proto, like so. And the syntax is that we start with the syntax in double quotes, that is proto3. And then we need to declare a package name, so package package. And the package name, I'm going to name it to main pb. Next, I need to declare option, so where I want the output to go. So go underscore package. And here in double quotes, I need to give two values, right? The first value is /proto/gen, and then using semicolon instead of the double quotes, I'm going to get the second value, enter the second value, which is gen.pb, so the package name of the generated file. With that, let's now declare service. So my service, I'm not going to create any unary RPC methods now. So up until now, we learned all the unary things, right? And unary simply means the simplest form of RPC, where the client sends one single request and then server sends one single response back. So we did that already. Now we're learning stream. And in here, I'm going to add a method. So I start with RPC, and the name of the method, it's going to be generate. And I want to name it Fibonacci, like so. The spelling is correct. Now, in between, the request to come should be Fibonacci request. And then I want to return using returns Fibonacci response. All right. And then I need to add a semicolon to end it. By the way, this service needs to have a name, and I'm going to name it what? Maybe calculator. Yeah. All right. So with that, I still have some error. Generate Fibonacci is the name. And then Fibonacci request returns. Oh yeah, I need to create all these things. Okay, now the thing. Because it is a server-side stream that we're learning, and server-side stream means the response will be streamed to the client, all right? The client sends a single request, and then the server is going to respond with a stream, so continuous flow of data. And so in here, I need to add the stream keyword, like so. And now let's create these messages. Message Fibonacci request. And in here, I want int 32n. So I want to send a random number, and the field number here is 1. n1 is not the value of n, but it's just the filled number. And then I'll also need a Fibonacci response, like so. And in here, the int32 should be a number. And again, it's 1 because it's a filled number. By the way, I'm going to capitalize them so I can access them from outside. And that looks about good. The only problem is I don't understand why is it that this thing... Yep, all good now. So that was our main.proto. All we have to do is now generate this. And actually here I should have made 2 folders, a server and also a client. And then the Go mod goes inside the server, right? And the Go mod also goes inside the client. So I need to delete this. I made a small mistake, my bad. Things often go wrong. So I grab this proto into my server. And I should now go inside a server. And in here I should then make Go mod in it. And now I'm not going to do streams. I'm just going to make it server. And again, I have to install the package go get google.golang.org/grpc, like so. So with that, inside of my server, the mod, it's now a proper Go module, and now I can generate the proto. So for the proto, I need to call protoc, the compiler, and then dash capital I, which is equals to proto, because that's the destination, or that's the folder, and then double dash go underscroll out is equals to dot, so right here, and then again double dash go dash grpc underscroll out is equals to dot. All right, and then space the name of the proto file, which is inside proto/main.proto, like so. And by the way, I'm just going to grab it, or no need. So let's enter, and the gen was created. Now inside of this server, let's create our main.go so we can initialize the server and run the whole process. And so the main file gets the package main, and it also gets the main func. And we know there are a few things we need. The first thing is we need a type server struct. We have been practicing it all along, all this time. And in there, we need to access the genpb. So not genpb, basically the genpb, but I'm going to alias it as pb. So import, and instead of this, I'm going to import pb. I'm naming it as pb, and this can be found if I go to server/proto/gen, like so. And so in here, I can access pb, and they're the unimplemented calculator server, this one. So that was first. The second thing is I need to also register it inside the main. And also I have to register this function, generate Fibonacci. Let's go one by one. Let's start with the function. So in here, the function generate Fibonacci, this right here, it should be a pointer receiver of this server struct. So func, and it gets the s, which is a pointer to server, followed by the name, generate Fibonacci. And here we get a few things. The first thing is the request, which is a pointer to our PB, and they're the... Where is my Fibonacci request? Dot. Yeah, Fibonacci request. And the other thing, which is the response, and this time the response is a stream, like so. And its type is PB and not Fibonacci response. That is not the type for response, although that would be the type for for all the things that we have learned up until now. Yeah, for all the things that we have learned up until now, we used pb dot Fibonacci response, but now we are not going to do it. Now we are going to access the package, and this time we're going to call calculator underscore generate Fibonacci server. This is what we need to access. And then the return type is just an error, if any. So for stream, please mind, this is the return type. The return type is the name of the service underscore name of the method and ends with the server. So with that, instead of this function, what do we want? Well, we want to generate a Fibonacci sequence. First, we will need a n variable, and this n is request, and there the n, so the number that is being sent from the client. And then we will need two additional variables, so p and a and b, and you can also make it x and y, whatever you want. I'm going to start at work with a and b, and I'm going to start at 1 and 0. Actually, this is what we should start from. Next, we want to iterate over the number that we get as a request, right? So here I want a for loop. And in this for loop, the I should be equals to 0. So this is where it should start. I is equals to 0, semicolon. Next, the I should be less than the int, converted int of n, then semicolon, and then I should plus plus. Now inside of this, what do we want? Well, the first thing is I want to stream some data out, right? I want to call the stream, and on that stream, I want to say send, stream.send, and that gets the pointer to my PB, and there the Fibonacci response, like so. And in this, I'm going to use this number, and on this number, I'm again going to int 32 the value of A, like so. So this is just the way Fibonacci works. Now this stream, it can give me an error, so I should handle it. And in here, I'm going to check it. If error is not equals to nil, so if error is not equals to nil, I'm just going to return the error. But if everything is good, we need to go to the next iteration, right? So to go to the next iteration, I need to again call the A and B variables. And now the value of A is the value of B, and the value of B is the sum of A and B. So A plus B. That's how it works. And then, because this is a very simple function, it's going to finish super quick. To simulate some processing, I'm going to sleep for 1 second. So time.sleep, and in here time.second, like so. And then after this for loop, I'm just going to return nil. So this is basically the entire Fibonacci sequence, and we are using for loop because we have to iterate over the numbers, right? We have to go from 0 to 1 up until n, and that is why we are using this for. And for every iteration, we are streaming the newly generated value. So as it is being generated, we're sending it right away. We're not waiting for the whole list to finish. So that was our function, generate Fibonacci function. Now let's work with the func main. Now to work with this func main, we know we need to open up a port in our computer, and then we also need to register the service, and then we also have to create a gRPC server that would listen using this open port. So 3 things to do. So in here, I need to access net package, and on that we get listen. And mind you, we are not going to generate the TLS certificates. We're just going to go with insecure. I've already shown you how to work with the TLS. So it's a TCP connection, and I'm going to put a port number of 5000, 5051, like so. And then this gives me a listener on the port and also an error, if any. So I should handle this error, and I'm going to bring this if error is not equals to nil. And in here, I'm going to say log.fatal line. And then I can say, maybe I can just pass the error. Next, with our port now open, I need to now create a server and register the service and also start listening. So let's access grpc package. And on that, we have a new server. And this then gives me the grpc server, which we will need for the register. And then I can access the genpb. And on that, I need to access the register calculator server, like so. And to this, we need to pass the grpc server that we just created, and also a pointer to the server struct, like so. And with this, with our server connect created, the port created, and the register registered, we can now listen on the port. So grpc server dot serve, and we want to serve it on that listener. And then again, this can give me an error. So let's handle it like this. And then this is the end of this server, and we can now run this server to see if everything is working. So in here, I'm just going to do go run dot. And our server is running. Next, let's work on the client. So I'm going to grab this, basically I'm going to launch this server in a file explorer so that I can grab the proto file, and I'm just going to paste it inside the client. Now I've already shown you how to generate the proto file all along. I don't want to waste any more time. I just want to grab it because there is no difference. We are using Go for both client side and server side. With that, let's open a new terminal, and in here, let's go to CD client. And again, we need to initialize a Go module in here for the client. So let's do that. Go mod init client. I'm just going to name it as client. And again, we have to get the package, which is this one. Go get google.golang.org/grpc. And with that, we have already brought the proto with the gen inside of it already. So now we can just create the main.go inside the client. So how does this work? Well, it's pretty simple. We need to declare package main and then our func main. And inside of func main, we're going to do everything. Now, inside of this func main, the first thing is to create a new client. So let's create grpc.new client. And on this new client, we need to pass the address, which is localhost for us, followed by the colon 50,051 port number. And again, we need to, since we are not generating TLS certificate, we should make it insecure. We need to pass an insecure value. So we need to access grpc. And on the grpc, we need to access with transport credential, if I can find that, with transport credentials. And to this with transport credential, we're going to pass insecure. And on that insecure, we have new credentials, like so. So this thing then, this new client gives me a connection and an error. So it gives me a connection and error. Let's handle the error first. And I'm going to say if error is not equals to nil, I can do log.fatal line, and I'm just going to add this error right here. Next, I should also close this connection when main function ends. So I can call differ. And on that, I can say connection.close. Basically, whenever in any Go program, whenever you get a connection, you must differ close it for any program. That being said, we have a client to work with. So I should bring the PB package. I should bring the gen package, and I will alias it by PB. So that would be client. So my module name /proto/gen. So now this PB, I can access it. PB, and on this PB, what do I get? If I think about it, for the connection and also the request response cycle, I will need a few things. I will need a context. So I think I'll create the context first before working with the client. So let's just do context, and on that context.background. So this is my CTX. By the way, yep, that is good. And with that, now let's create the client. So I'm going to access PB, and on that PB, I get the new calculator client. Now this new calculator client needs the connection, which I'm going to give it like this. And then this gives me calculator client, right? So calculator, maybe calc client, I can name it. And other than this, nothing else. So this is the only value we're getting, like so. Next, we need to create a request and then send it. So I'm just going to make a rec here. And I will again access the PB by using the pointer. So pointer to PB. And on that, we have a Fibonacci request. And on this, I'll pass n. And maybe the value of n can be 10. So I want to generate up until 10. Next, let's call the client that we get, which is a calc client. And on this calc client, I now want to call the generate Fibonacci. And to this, I will pass the context and the request that we created up here. So this then would give me it gives me a stream, which is the response, and an error. So I get the stream. Actually, I'm just going to name it client for now to keep things simple. So it gives me a string and stream and an error. And I'll handle the error right here. Next, let's work with the stream. So the stream, if you think about it, the stream, it's sending me non-stop data. It's like a channel, right? It's sending me data as long as there is data being produced. So it's sending me data over and over and over again. And so I will use a for loop in here, an indefinite for loop. By the way, inside of the for loop, we will check when the data has finished. And in this, we have a stream, and on that stream, we get the receive method, like so. This gives us a single response and also an error, if any. And on this error, we should check if error is not equals to nil. I can do a log.fatal_n, and that's fine. By the way, there is also a second type of error which we should check before this error, which is end of file error. Because that's not an error, it simply means there is nothing else coming from the stream. So here I'm going to check if error is equals to IO. So I need to access the IO package, and there the EOF. Yeah, IO.EOF. It means end of file. It's not an error, it's just we're checking if everything is finished. End of file. If this is the case, I want to do log.println, and in here I'm going to say end of stream, and then I'm going to break out of this for loop. All right. And with both of this, with the errors handled, inside of the for loop, I then want to print this response. So I'm going to do log.println, and on this println, I'm going to do Fibonacci number. And then in here, I'm going to get response. And on that response, I have the generate get number. not generate number, but get number. Because we're using int32, internally gRPC knows you can get each number. So this get number, which is a getter. With that, let's now launch our client because it is now complete. So here is the main function. And let's run this. Go run dot. So it starts at 1. Yep. So 10 numbers, and those were the numbers, each with 1 second break in between. And then at the end, we get end of stream, because for the last one, it checked if the error is of type end of file, which is true. And then we get this print end of stream, and then we break out of this for loop. As a result, we break out of our program. All right. Now let's move on to client-side streaming. So last time we learned server-side streaming, which meant that the client sent one single request to the server, and then the server sent a stream of data back to the client. Now, the client is going to send a stream of data to the server, and once the stream finishes, the server is going to process all the things and then send one single request back to the client. Now we already have our client and server ready. It's just that we need to add a few things. So in the server, and there in the proto, main.proto, instead of our service calculator, I'm going to add a new RPC method, RPC. And I'm going to name it maybe send numbers. And then the request type, it's going to be a stream. This time the request is coming as a stream, not the response. And then I want to send number response, like so. And then I want to return using returns number. This should be number response, and this one should be number request, like so. Now let's create the messages for number request and number response. So message number request. The idea is the client is going to send int32 numbers. So a number, and I'll give it a filled number of 1 because it's a new message struct, or new message, you could say. And then another message for the number response right here. And instead of this, I want 2 items. As a response, I want to send the sum. So int32, not 2 items, 1 item. Sum, and here the field value is 1 again because it's the only field value. So with that, let's generate this proto file. There we go. And now back into the main.go of the server, let's create that send numbers function. This should be send, not send. All right. So this function should be a pointer receiver of the server struct, just like before. So I'm just going to grab this all, and this should be send numbers like this. And instead of this time, here, because it's a client-side streaming, we get only one single parameter, and I'm going to name it as a stream. And this stream is going to carry the request. All right, it's not the request itself. The stream is going to carry each request. So it's a stream, and I need to access PB. And there, the calculator and send number server, right? So the service name underscore the function name, and because we are server, so the server. And inside of this, let me get rid of all the things and start fresh. So the thing is, we want to bring the stream and we want to receive from here, like so, because we want to receive the numbers that is incoming. So this gives me each of the single request item and also an error. So let's handle the error first. So if error is not equals to nil, I'm just going to log.fatalf. Next, I want to print the numbers. So I'm just going to do log.println. And instead of this, I want to access the rec.getNumber. And I get this getNumber automatically because gRPC under the hood knows that we are getting int32s, and hence we can access getNumber. Now, by the way, for each of the number I'm getting, I also want a total sum of it. So I'm just going to make a sum here. And this should be an int32, and it's a variable. And then at the end, I can do sum is plus equals to rec.getNumber. So each of the number that I'm getting, I'm adding it to the sum. Now, this is going to be a for loop because it's a continuous stream. Like so. And how do I understand when the stream finishes? Well, every stream gets an end of file. So in here, I can check if error is equals to IO package, and there the EOF. So if that's the case, it means the stream has finished. And if this is the case, I'm going to send my response back, one single response back. So on the stream, I can do send and close. And you can see this send and close takes a pb.number response. And so in here, I'm going to access pointer pb.number response. And on this, I want to send the sum, which is this sum, like so. And then that is the end. We don't have to register anything because we have already registered the calculator service before already. So that's the end of this server. And I'm going to run the server, go run dot. And with that, let's work with the client. And I'm going to grab this entire proto file. So I'm just going to reveal it in the file explorer. And inside of our client, I'm going to remove the proto and add that back because it has all the new methods and everything. So let's go to the main.go of our client and configure this to handle the new stream. So in here, I'm going to make a separation like so. And now let's begin. Now the idea is I want to access the client again because we have one single client because we have one single service, right? We get new client for new services because we have one service, so we work with one single client. And on this client, I want to access send numbers. And you could say I want to send, actually here I need to pass the context. So this gives me a new stream. This send number gives me a new stream, which is a single request. And it gives me a response back and maybe an error. So basically I get a new stream and I'm going to name it stream1 and then an error. And I'll handle the error. If error is not equals to nil, I'm just going to log.fatalf. Next, I need to now send the stream back to the, basically I need to stream from this client to the server, right? And for that, I'm going to use a range. So I'm going to use a for loop and I'm going to range on numbers. So num, and this is going to be a range over 9. So 0 to 9. And inside of this, I'm going to call this stream1 that I created here for send numbers. And on this, I can access send method. And I need to send a pointer to pb.number request. And on this, I get each number field. And to this, I'm going to pass the number by converting it to int32, like so. This again might give me an error, so I should handle it. And I'll check here if error is not equals to nil, log.fataln. So that's one thing. Now the other thing is, inside of this for loop, I want to go to the next iteration of the loop by sleeping. Because I don't want to send everything right away, I want to simulate some time. So time.sleep, and that would be time.second, like so. So after the range finishes, the stream will finish, and then I will expect a response back. So on that stream 1, I'm going to expect close and receive. So I'm going to receive something and then I'm going to close it. So that gives me the response or maybe an error, like so. And then again, if the error is not equals to nil, I want to handle it. And then if I have a proper response, I want to print it out. So log.println, and in here I'm going to say, maybe I could say client server resp after stream, like so. And then in here, I'm going to access res, and on that res, I get the sum. So that is it. And by the way, I'm also going to add this here. So that is all for the client-side implementation. And now let's run our client. So let's access go run dot. Now the first one is going to be for the first stream, which was server side, which is a Fibonacci number. By the way, in the server, oh, I'm not printing anything in here. Yeah, now I am. 0, 1, 2, 3, 4. It's coming. Yeah, you see, this is the server terminal, and here I'm getting the stream from the client. And once it's done, I then send the addition back to the client. So that was it for client-side streaming. So with server-side streaming and client-side streaming now covered, we can now safely move to bidirectional streaming. And now this time, no one is going to send one single request or one single response back and then get a stream on the other side. That's not the case. Now we are going to hold a persistent stream between the client and the server. And I'm going to show you a very simple example that the idea is whenever the client and the server starts, yeah, the client is going to send some hard-coded value. Of course, you can make it a full-fledged chat app. I'm not going to do that. I'm going to have 3 hard-coded value: hi, how are you, and bye. So the client is going to send a stream of this 3 text to the server. The server will actively listen for whatever is incoming, and whatever is incoming from the client, the server is going to take it and send it back to the user continuously. All right? So it's a very short, simple stream. Let's open server and let's go to the proto file, main.proto. And I'm going to add a RPC method in here, RPC. And maybe I'll name it transmit, TRNSMIT. Let's just say chat. Yep. And this time the request would be a stream, and that would be chat message type. And then we want to return using returns, again a chat message, and this would also be a stream, like so. And this is an example of a bi-directional stream. So what is a chat message? A chat message is a message with one field, which is named as message, and this is a string, and that's all. And of course, it gets field number of 1 because that's the only thing. So with that, our main.proto is ready. And by the way, this calculator doesn't fit here anymore, but it doesn't matter. Let it stay as it is. So let's generate the gen folder, and we are good to go. By the way, I'm also going to copy this proto to the client. So let me reveal it in a file explorer. I'll grab this proto and add it to the client folder as well with the generated files. So with that, our server, the server is already ready with everything implemented except the chat function. And that is going to be another pointer receiver of this server struct. So let's work on that. It's a new func, and it's a pointer receiver of this s, which is a pointer to the server. And we called it chat, right? Let me check. Yes. And this chat gets a stream. We will name it a stream. And the type here is a PB, and they're the calculator package. So a calculator and chat server. So calculator is the name of the package, followed by the name of the function with underscore, and then a server, because we're in the server. And that's all. Next, we want to have an error, if any. And now in here, what do we do? Well, the first thing is it's going to get a for loop because it's a continuous stream. And in here, we will have two parts. First, the receiving part, and then after we receive, we go to the sending part, and then we go to the next iteration of the loop, right? So RECIE, RECEIVE, right? Receive. And so we can access this stream, and on that we get the receive method. Now this then gives us a single message, or maybe you could say rec, and also an error. So we should handle them. And if error is not equals to nil, I'm just going to log.fatal ln, and pass the error right there. By the way, in here, because it's a stream, we should also check for EOF. So if error is equals to io.eof, I want to return nil, right? So that's one thing. And after that, we received it properly. Let's go to the send part. By the way, between this, I'm also going to log.println, and I'm going to say client said, and I'm going to print out the request, and there the get message. Now this get message is something gRPC is giving us because the type of chat message is message, right? String. So it knows under the hood that we can get message for each incoming request in the stream, right? Next, let's work on the send. So this time I want to access the stream, and instead of receive, I want to access send. And on this, we want to access pointer to the pb.chat message. And this then takes a message, and the message, I'm just going to say here server replied, and this gets the plus, which is a rec dot get message. I should access each individual message using get message, like so. And with that, this stream.send might also give me an error, so I should handle it like this. And it's a old value, so we just use that. And in here, I think instead of logging, I should maybe this thing returns actually, right? No worries, let's just use return error. Yeah. Now I'm just going to use this. So maybe for the EOF, let me check if we have a EOF. Okay, that's good. So that's all for the server side. Let's now run our server. So go run dot. And our server is running. Let's now go to the client. And for the client, what do we do? Well, it's pretty simple. For the client now, I'm going to get one more of this. Also, I'm going to add one here just to separate them out properly. So in here, what do we do? Well, the idea is I now need to make a new stream. So I want to access the client, and on that client, I have the chat function, right? Chat method, which takes a context. So this then gives me a chat stream. So maybe I can say stream2, like so, and I also get an error. Now I should handle the error. So if error is not equals to nil, log.fatal ln followed by the error. And after that, I now want to create a Go routine, and the job of the Go routine is to receive whatever is coming from the server, right? And then whatever is coming from the server, we just print it out, independent of what we are sending to the server, right? So we can either work with the receive first or the send first. I'm going to work with the sending first. Let's say we have messages variable, and this is some hard-coded messages that we are going to send, and this is going to be a slice of string. And in here we have hi, we have how are you, and then we also have a bye, like this. Next, let's send them. So we need to use a for loop, and I don't care about the index, but I care about each of the value, which is m, so the each of the message. And I get this when I range over this messages variable, right? Like so. And then inside of this, I'm going to access the stream. So this stream2, this one that we created, stream2. And I think this should be stream3, right? That makes sense. It should be stream3. This should be stream2, like this. And yeah, that's good. So anyways, on the stream3, I want to access send, and I want to send each of the value using a pointer to pb.chat message, and on that message I have message field to which I want to pass this m, single m that we are currently iterating over. Now this stream might give me an error, so I should handle it, and I'm just going to handle it simply like this. And after this, I want to sleep sometime, so time.sleep to simulate some processing, like so. And then here, after the for loop, outside of the for loop, I want to access stream, so the stream3 that we have, and on that, close send, like so. And this would be the EOF. So this is here for sending things to the server. What about receiving? Well, for receiving, I can access make a Go routine. And you can make the Go routine wherever you want. It doesn't matter because Go routine, as you know, will be extracted out of here and it will run in a separate thread, not in the main Go. So let's create a Go func. Go func. And the syntax of Go func is this. Now in the function body, I want to again create a for loop and listen for with the stream. So I'm going to access the stream3, and on that I am going to access receive. Now this then gives me each of the message that is incoming, or you could say response, but I'm just going to write it as message and also an error. So let's handle the error like so. And we should also handle the EOF. So if error is equals to io.eof, I want to just return out of it. So next, if we don't have any error and we're in the loop, what do? Well, it's very simple. I just want to log.println, and in here I'm going to say server, like this, and then access the message, and on that the get message method or function. So with that, now if we run our client, what's going to happen is first we will work with the server side, then the client side, and then the chat is going to work. All right, so let's run this. So those are now numbers. And for some reason that was the end of stream. Yeah, now we are starting with the hi, how are you, bye. As you can see, it came one by one, right? Because we sent one by one to the server, then the server sent us back one by one. So that was both side streaming with bi-directional streaming. Now, gRPC also has some advanced features, for example, deadlines and timeouts, compressions to make the transmission of data even faster and even smaller, reflections, and compatibility with RESTful APIs. Now, let's have a look at a few of these. Let's have a look at how we can enable compression on the server side. It's very easy actually. All we have to do is grab the gRPC package, and on that we can access /encoding/gzip, and that's it. Now the thing is, if I save now, this thing is gonna go. If I save, it's gone. And to keep it, we add a underscroll at the very beginning, and that's it. And that is really it. On the server side, we don't have to do anything else. Just this import here does all the trick. It compresses the responses that we send from the server to the client, and they become faster and smaller. Next, let's look at how to compress all the requests that goes from the client to the server. So now I'm in the client side main.go, and in here where we create the new client, if I hover on this client, you see we have the option to send gRPC dial options. So this is where we will work. By the way, I'm just going to grab it. Quickly, I'm going to grab it. And I'm going to copy it out and paste it one more time. So the thing is, in here, we want to access the gRPC, and they're the with default options. And inside of this method with default options, we can again access the gRPC, and here we can call use compressor. Now inside of this use compressor, we want to access gzip. Now please keep in mind there are three gzips. We want the one from the gRPC package, and they're the encoding/gzip or gunzip. And on this, we want to access the name. Now just like that, and I think this should be here, yeah. So just like that, at this point, all our requests that would go from this client to the server would now be compressed. But if you don't want to compress all the requests but selected few, we can also do that. So let's have a look at that next. So again, I'm going to just maybe comment it out, and I'm going to uncomment this one. Like so. All right, next let's have a look at how to compress selected request. So on the client side main.go, if I come down, perhaps here on this client, I'm accessing the add method, right? Here I'm accessing the add method. And below, are we accessing anything else? Here also we are accessing the new greeter client. So we can, just a moment, add client, and on this we have add. And in here, I have the greet. So on both of this, on this greet, I have these options of gRPC call options. Also on that add, I have gRPC call options. So let's work with either one of this. And I'm just going to quickly copy it and comment one out. So in here, what I can do is I can comma it and then access gRPC. And in here, use the use compressor. And to this, I can then pass the gzip from the encoding/gzip of gRPC. And on this, I can then access the name. And now this request would be compressed. So there you go. With this, we get to compress all the requests, or you can compress individually like this. Now let's have a look at how we can send metadata from client to the server. And metadata are key value pair, such as your authorization token and so on. Now, to send such a thing, we need to send it with the context of the request that we're sending from the client to the server. And so in here, first, let's create some metadata. I'm going to create this MD. like so. And then I need to access the metadata package from grpc. So grpc/metadata, this one. And on that, I can access pairs. And here you can create as many pairs as you want. For example, authorization, and this gets a value. For example, bearer, bearer, and then some token, right? Like so. By the way, this then forms, both of this together forms one single pair, and you can add as many pairs as you want. For example, another pair, test1, and this gets another value of 1, 2, 3, 4, whatever, like so. So 2 together forms a pair, and you can add as many pairs as you want. Now with this metadata, I'm just going to stick with one single pair. Now, how do we send this metadata? Well, we send this metadata with the context of the request. So in here, I'm going to create a new context, ctx, and then again, we need to access the metadata, and there the new outgoing context. This then gets the prior created context, so the old created context, this one, and the metadata that is to be carried, md. And that's it. And then this context is going in the request. So that's all we need to do from the client side. Next, to extract it in the server side, let's go to the server side. And we are sending it in the add request. So in the add function, this is where we need to extract it. So the thing is, at the very top, I'm going to access the MD, so a variable of MD. And actually, let's just access metadata package first of all from grpc/metadata. And on that, we want to access from incoming context, right? Because now we are unwrapping what we are getting from the client into the server. So we want to access the incoming context. And on this, we then want to pass the context that we already have. So this then gives us the metadata and a bool. So an MD and an OK. And then I want to check using the bool. So if not OK, I can say log.println. And in here, I can maybe write no metadata found. But in case if it was OK, I can then print log.println. And in here, I can print the entire metadata. For example, metadata is this MD. So that's one way. The other way is to access each individual key within the metadata. For example, MD. And in here, I can access the name of the key, which was this authorization. This is something we can do. Like so. This then gives us the auth header. So auth header, and again an OK. Next, I can check this OK. And if we have the auth header, I can then print this auth header like that. So that's one way. The other way would be, for example, in here, I can just access the metadata at the 0 index. That's also something we can do. So you can use either one of this. By the way, I'm just going to comment it out. So this is how we send metadata from the client, and then this is how we access those metadata in the server. By the way, we can also send headers or set headers from the server to the client. So for example, on this add function, when we send a response back to the client, here we can set headers, which we can then unwrap in the client when we get the response in the client. So how do we do it? Let's have a look at the server side first of all, because this is where we want to send it out to, right? And in here we are sending our response. So right here, I'm going to create a new comment, and I'm going to say set headers, or maybe set response headers, like so. And first I'm going to create or set the pairs. So I'm going to access the metadata, and on this we can set the pairs. And pairs are just like before, key value pairs. So maybe I can say key 1 and then value 1 and then key 2 value 2 pairs all along, all right? And this then gets a response headers variable. And now this is what we can send. So I can access grpc, and on this I have the send header method. To this we can pass the context and then the response headers variable. And then this gives us an error which we need to handle. So error, like so. And now to handle it, I'm just going to bring this. And I'm going to say here, if error is not equals to nil, I can say log.println could not set headers. Just like that. And that is all for sending headers from the server to the client. All we have to do is now go to the client and extract it. So in the client side, here, this is where we get our response. So this is where we need to extract it. So first I'm going to create a variable because we will need its pointer to extract the headers and put it in a variable. And this is where I'm creating the variable first of all. So res headers. And the value type here is metadata.md. Next, let's extract it and put it inside of this variable. So this is a add client. And on this add client, if I we don't have to access this add client. We already have this add client.add. So just in here, I'm going to access grpc. And on this grpc, I have this header function. To this, I'm just going to pass the pointer to our res header, like so. And now this add function, so the response of this add function comes with some header from the server, and that is what we are then populating into this variable. And then rest is easy, we can then print it out. So after the error handling, we can print out all those things. Maybe we can do log.println, and in here I can say res headers, and then we can print this res headers. This is one way to do it. The other way would be to access res headers at a pointer, so at an index, and actually by the name. With double quotes. So these are two ways of accessing the response headers. Now the last thing regarding metadata would be sending trailers. Now trailers are very similar to headers. The only difference is trailers are sent after the response, with the response after the request body. All right? And it's just like headers, but like I said, it goes with the response after the request body, so as additional informations. So in here, we can create another response trailer variable. So maybe response trailers, right? In the add function of the server's main.go. And this too looks pretty much the same. We access metadata pairs and then key 1, value 1, key 2, value 2, and all other things that you might want to add. And then we access grpc.setTrailer. To this, we then pass the context and then this response trailers. Now this thing again can give us an error, so that is something we should handle. And I'm just going to handle it right in here. So could not set trailers. And that's all for the trailers to be attached with the response. Now we just have to access it in the client, and we access it the same way as the response header. So I'm going to create var res trailers, and this is metadata.md. And actually I should keep it right in here. Because inside of this add here, I'm then going to access grpc dot trailers trailer, and in here I'm going to give it the pointer of res trailers. And with that, then I can again access it like so. So res trailers, which is this res trailers. And by the way, this res trailers is also what I can access in here, and in here I can say res trailers. And that's all for response trailers. Response headers and trailers, adding them and extracting them is exactly the same, other than the set name here, set trailer and set header. And the other difference is trailers are attached outside the main response body. Let's have a quick look at how we can use Postman to test gRPC endpoints. So make sure that your server is up and running, and we're using the gRPC practice server. And you should have one of the latest versions of Postman, because there the gRPC support is solid. So I'm going to hit this plus, and I'm going to choose this gRPC. Now this server uses TLS, so I need to make sure that TLS is enabled. And the URL is grpc:/localhost:50,051. Next, I have to add a method. For this, I need to import a proto file. So let's do that. So I'm going to import my proto file, which is this main.proto. And then I can access the method, which is add. Now please see, if I hover over this, it correctly identifies that it is a unary operation, because it's a single arrow up and single arrow down, so single request response. Otherwise, it would have two arrows for client side, server side, or bidirectional, depending on which side it is. Anyways, let's add this add and invoke. So I sent nothing and I got sum as 0. By the way, metadata is also here. Application grpc value 1. Also have a trailer q1 value 1. Anyways, I don't want this 0. I want a proper number. So let's go to message. Let's go to docs. If I come to docs, I can see that it takes int32a, int32b, and then it gives me back sum, which is also int32. So to add the values here, we can go to message and use this use example message. And as soon as I click this use example message, it populates the message with proper values a and b with integer 32s. And now we can edit this, maybe 10, and let's go with 50, like so. And now if we invoke this, we get the correct result back. The sum is 60 of 10 and 50. And again, please remember, because our server is using TLS, we have enabled TLS here. For other server, if you don't have TLS enabled, you can keep it disabled as well. Now, before we move any further, I would like to point out this package, which is named as protovalidate, and it can be found if you visit github.com/buffbuild/protovalidate. And this package helps you validate the fields within your message, as you can see. Now, I won't be demonstrating it by using it in this course, but I just would like to point out if anyone would be interested in using it. Now, by the way, if you scroll down just a bit, you will see that this plugin supports quite a few languages. And for us, and especially for me, I'm more interested in this protovalidate-go, because that is the package for Go language. And then you can read the docs and apply it yourself. And as you can see, it is pretty easy. You just mention your field with the field number, and then in square brackets, you mention some validation logic that actually looks very easy.